Right, so we've got an aeroplane. It's flying in the air, and it says that the air is moving due east. The air is moving due east. So, similar to the river crossing, that's in essence the current. So it's moving due east with a speed v meters per second. The velocity of the aeroplane relative to the air is 150 meters due north. So that is the direction in which the aeroplane is attempting to head. The aeroplane actually travels on a bearing of 30 degrees, which makes sense if that's the resultant. So imagine you're trying to aim north, but there's this wind, this air dragging you east. Then you can see that there you can see that this path here, okay, the resultant would make sense. You're aiming north, the wind's bringing you east, so you end up travelling in this direction. So that's on the bearing 30 degrees. Okay, so we're going to show that V is 86.6. So we've got an angle, we've got a side, and we're looking for another side, so we're going to use trig. Because obviously we've got this right angle triangle because we've got north and east. So we've got the opposite and the adjacent, so we'd use tan. So tan 30 would be opposite over adjacent, V over 150. Rearranging that, V would be 150 lots of tan 30. And rounded to three significant figures, you get 86.6 meters per second. Right, we're now asked to find the magnitude of the resultant velocity of the plane. So that's our hypotenuse of our right angle triangle. So we now know the two other sides, so it's just a case of using Pythagoras. As we've used big V already, I'll use little v to denote the resultant velocity. Okay, so because we're looking for the hypotenuse, I'm going to add the other two numbers squared. You get 173.2051 blah 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 blah, and to three significant figures then it would be 173 meters per second.